Good morning, and welcome everyone to this month's Alaska Collaborative on Health and the Environment webinar entitled Adverse Effects of PFAS on Immune System Health, Complicating Recovery During the COVID-19 Pandemic. My name is Nick Reardon, and on behalf of Alaska Community Action on Toxics, I'll be hosting this gathering. And I'm calling in from my hometown of Anchorage, Alaska. And these are the traditional lands of the Dena'ina. And I want to just take a minute to acknowledge and express my gratitude towards the Native peoples on whose lands myself and my colleagues live, work, and play. I am also very grateful to be joined by our special guest, one of the world's preeminent scientists, Dr. Philippe Grandjean. He's joining us from across the Atlantic and is graciously giving up his dinner plans to present a portion of his extensive research into human health effects of PFAS and answering questions and comments from you, the audience. For those of you not familiar, SHEA Alaska is a regional partnership group of the National Collaborative on Health and the Environment. And our organization's aims are to advance knowledge and effective action around the links between human health and a range of environmental factors. More information and a wide variety of resources are available on our websites, so akaction.org and healthandenvironment.org. As usual, our session will last an hour, and we've reserved some time in the second half for discussion and Q&A with listeners. For those of you joining on Zoom, you can type your questions directly into the chat box, and I'll pose them to our guest. Let's see. Yeah, a bit more about our speaker. Dr. Philippe Grandjean, he's the head of Environmental Medicine Research Unit at the University of Southern Denmark and adjunct professor of environmental health at Harvard T.H. Chan School of Public Health. He's also the co-founder and co-editor-in-chief of the journal Environmental Health and has served for over 30 years as toxicology consultant at the National Board of Health in Denmark. His decades of research have focused on adverse health effects from exposures to environmental chemicals such as PFAS, especially those effects occurring during vulnerable stages of human life. So examples of this might be the effects of methylmercury, endocrine disrupting pesticides, and their adverse effects on brain development in children, as well as the topic of today's webinar, the effects of per and polyalkyl substances on immune response. So some of the slides in his presentation are still awaiting publication or are under copyright. So consider the slides for today's call for personal use only. So welcome, Dr. Grandjean, and yeah, thank you so much for joining us today. Yeah, I invite you to share your screen and yeah, begin your presentation when ready.
Thank you for welcoming me. It's a pleasure to be part of this seminar, this webinar. I've been a guest at SHEA before, and I've always found the webinars to be informative and the audience to be very responsive and well-oriented. So I can tell that this is going to be a useful webinar also to myself. I will look forward to the questions that you might have. I would say that in regard to the immune system and the PFAS, we don't have a complete understanding. We don't know exactly what the mechanisms are, but these PFAS have a variety of known molecular effects. So I would say that the key characteristics point toward these compounds being capable of having such effects. And if we don't know the details about the mechanisms, I would say, isn't it enough for us to know that they actually are associated with particular outcomes that are worrisome in regard to human health? So with that introduction, I would like to start showing my screen. And for those of you who are not on Zoom, you can see the slides on the PDF that has been made available for distribution. I took this picture several years ago of these kids having pizza. And at that time, pizza boxes in Denmark, this is from Copenhagen, at that time, pizza boxes were treated with PFAS inside, so that when you're walking home with your pizza, that any wetness would not make the cardboard sort of open up and the pizza fall through the pizza box. This is not legal anymore in Denmark, and it will soon also be the case for all of the EU. It's being phased out, that technology. You cannot use it in, at least that's a plan, in food wrapping materials, including pizza boxes. So I just wanted, for formality reasons, to say a few things about my own background, and Nick actually summarized it very well. I've added that sentence at the very bottom that some of these slides have copyright issues and should not be distributed, but you're perfectly welcome to use my slides for your personal uses, as long as you're not distributing them via the internet. So the history here about the PFAS is that they've been produced since the 1950s. And I think it was about 1968 that it was discovered by advanced chemistry technology that they occurred in workers' blood. And so in human blood and in workers' blood. And in the beginning, some suspicion was directed toward a product called Scotchgard. And the company producing Scotchgard said it can't be, because that would not occur in blood. So there was some mystery about a paper that was published in Nature in 1968 by a chemistry professor from Rochester, New York. What were these organic fluorine compounds, and where do they come from? Now, later on, there was a situation in West Virginia with a female worker who gave birth to a child, and there were some concerns about the child's health, and they actually measured PFOA in cord blood. And 1993, they did a study at a commercial laboratory on behalf of one of the companies that produce these compounds, and they showed that PFASs could be excreted in milk. This was a goat model that they used. Later on, it was found that these compounds occur in human blood across the nation from Red Cross blood donors. They were even found in blood from albatrosses from the Pacific Ocean. I'm not sure they came from Alaska, but somewhere on the West Coast. And so finally, in 2004, there was a detection of PFAS in human milk. And in 2015, it was determined that breastfeeding was actually contributing a major part of the exposure to infants. Now, as you can see, I've shaded part of this table. And the reason I've shaded that is that that material was not published. So it only came to the knowledge of the general public and to academic colleagues after year 2000. There is a file at the US EPA that contains a material that was released primarily from 3M, where you can find information on these studies that were not published in scientific journals. So from this evidence, I think a major issue that I would like to emphasize is that the transfer of PFAS into human milk is of major concern. These are results that we published in 2015 on breastfeeding, and you can see that there's a dotted line in the bottom here. This is a child that wasn't really breastfed at all, and this child here was breastfed for a long time. This is a log scale, so you can see that the increase from the time of birth up to the peak up here, it's something like a tenfold increase. And it looks like mothers can actually transfer about half of their PFAS body burden to the child by breastfeeding, and the child may then end up with a tenfold increase or more in the PFAS concentration in the blood. So I think that's a toxicokinetic issue that we need to be very much aware of. This was picked up by the European Food Safety Authority that published its final opinion on the PFASs this fall, a few months ago. And they modeled what would happen to PFOA, in this case in a girl and in a adult woman. So the girl would start out with a serum concentration similar to the mother's, slightly different, but same order of magnitude. And through breastfeeding for 6 months, you can see that there is this steep increase. And then with time, because the body grows, there's some dilution, the PFOA concentration would then lower, and then there's a buildup through lifetime. Now, this slide is from EFSA, and they used that calculation, which is similar to what has been done in Minnesota at the health department. They used that for risk assessment purposes, and they pointed at immunotoxicity as the critical effect. And there are two reasons for that. Number one, the immune system is highly sensitive to some industrial chemicals, including the PFASs, but also when you develop your immune system, it starts, of course, prenatally. And that's what you're born with natural killer cells, a general type of immunity. But after birth, that is when the adaptive immune system develops. That's when the body decides what is self, what is non-self, what are the pathogens I should protect my body against. That cannot happen prenatally. So it must happen during infancy and perhaps also in early childhood. And you can see from this slide that that is a very vulnerable period for PFAS exposures to peak. So I wanted to share with you some information on immunotoxicity. There was actually a study done already in 1978 where it turned out that PFOA was extremely toxic to the immune system, or the reticuloendothelial system, as it was called back then, of monkeys. And a physician who was doing his PhD work in occupational health found that there were white blood cell changes associated with the PFOA exposure in 3M workers. Both of these studies were not published. Fortunately, the worker study is available as part of a PhD thesis that you can get a copy of. It wasn't published in a scholarly journal. The monkey study is available through EPA. So this was not shared with the public for reasons that we can perhaps discuss another time. But in 2008, a study was done on a mouse model, and what you do in a mouse model is that you inject sheep erythrocytes into the mouse, and then you measure the IgM. And it was very clear that PFASs were strong immunotoxicants in that model. So we were looking in a birth cohort from the Faroe Islands, we were looking at immunotoxicity, and we were concerned about the elevated PCB exposures because dioxin is a well-documented immunotoxicant. Some of the PCBs are dioxin-like. And so we were looking at a standard procedure to detect immunotoxicity. We were looking at children's responses to the standard, the routine immunizations that children undergo. And so we had found that PCBs had a weak effect. And after we saw the mouse study, we thought, oh boy, we better look at PFASs. And we did. And my colleague, who was a professor of immunology at the National Hospital in Copenhagen, he fell off his chair. He said, are those kids exposed to ionizing radiation or cancer medicine or something? And I said, no, they're exposed to some chemical pollutants that you yourself also have in your blood. And so he said, that can't be. But anyway, we continued pursuing this. And we published the first study in 2012. And the year after, we did benchmark dose calculations the way that EPA wants you to do it so that they can generate a reference dose, a procedure also adopted by the European Union. And we showed that a benchmark dose would have to secure that blood concentrations of PFAS and PFOA would be below 1 nanogram per liter of blood, which was very low, much lower than what was the basis for risk assessment at the point. So in this year, EFSA said, hey, this is a critical effect. Let me just say a few things of the immune system so that we're all on the same basis. Now, if you have an antigen exposure, then that can trigger an immune cell response. And if you are looking for antibody protection, that happens through B cell activation. Sometimes T cells are involved too in kicking the B cells to get into action, and they develop into plasma cells that are the real producers of the antibodies. A key molecule here is the NF-kappa B molecule that you may know of. We think that may be the primary target of the PFAS immunotoxicity, but we don't know that yet. Some more experiments are needed, and I hope will be done in the future. Now, we wanted to see what can we expect in regard to the antibody response when we vaccinate a person, for example, with tetanus or diphtheria. And tetanus and diphtheria are standard models because both of them are toxoids, meaning they're proteins. So they're proteins that trigger this antibody response through B cells turning into plasma cells that develop this specific antibody. And so this is what we did. We rounded up 12 colleagues at the National Hospital in Copenhagen, and we said, would you mind getting a shot of tetanus and diphtheria vaccine? And all of them had done their, routine immunizations as kids. And so they started at slightly different levels of initial IgG concentrations. This is what you can see here on the left. They started at different levels. And then they got the shot here at time 0. And you can see it takes like maybe as much as a week, but sometimes somewhat less. And we got these serial serum samples from them up to 1 month after the booster vaccination. And you can see different curves here. And note this one here, this is completely flat. And so we wondered what's going on. This wonderful curve, the orange curve, really shows a strong response. This is what we would like to see. This is what we are used to seeing in children. But some of these people, I mean, look at this curve. This is pretty fat too. So there are various curve shapes. And then we decided to measure the PFAS concentration in the blood from these colleagues. Whoops. Okay. What we found was that the steepness of this curve was inversely associated with the PFAS concentration in serum. So the higher concentration that they had to begin with, and hey, these were, normal medical care staff at a university hospital. They had no occupational exposure. It wasn't like they were eating pizza every day. This was just background exposures. And the more PFAS in the blood, the flatter the curve. And so this kind of got us going, that there is something that we ought to pick up. Why did we not see this before? This was like, we published this in 2015. Well, there was a chance to do that because at 3M, Gary Olson and his colleagues at the Occupational Health Department actually did a study on flu vaccination and its possible effect on absenteeism. And they published this in the Journal of Occupational and Environmental Medicine, and they did not say anything about those 3M employees who had been vaccinated and who might have been exposed to PFAS. So there was an opportunity, and it wasn't taken. I can tell you more about the publications from 3M. It looks like they have optimistically interpreted some of the data that have come out, for example, on liver enzymes and cholesterol. When looking back at these publications, it's very questionable whether they belong in academic journals or whether they were affected by company propaganda. So we decided to look at this in the Faroe Islands, where we have recruited both cohorts since 1985 for quite a long period. And the reason that we've done that is that it's a Western population in a North Atlantic fishing community, and it's a population of 50,000, and they know each other, and the mothers bring their kids for health examinations very happily. So we have very good follow-up and recruitment of cohorts. So this is the setting. The reason some of them have elevated PFAS exposures is that they eat a lot of fish. Some of them also eat pilot whale meat. It's an old tradition, hundreds of years old. And pilot whale is a toothed whale. And so it's the very top of the marine food chain. And PFAS concentrations, some of the PFAS, it's not PFOA so much, they are very high in the meat of the pilot whale. So this is an important source in that community, in addition to the marine food in general, plus whatever consumer products. So just to show you the principle, what happens with the childhood scheduled immunizations, you see an increase in the antibody concentration over time, and you hope to generate a concentration above that dotted red line to achieve protection. And we found kids at age 7 who had, despite 4 vaccinations, who had no protection or insufficient protection because the antibody concentration was below that dotted line, despite 4 vaccinations. And that was associated with their elevated PFAS exposure that in part originated from breastfeeding. So this is a slide from the first paper we did, and you can see that for each doubling, these are logarithmic scales, for each doubling of the, in this case, it's the PFAS concentration, each doubling, you lose about 50% of the antibody concentration. So you can understand a few doublings, and then you may get below that dotted line and not have achieved the protection that you were meant to get after the scheduled childhood vaccinations. So all of this evidence was reviewed by the National Toxicology Program, and because humans are exposed to more than one PFAS at the time, they concluded that it's a presumed human hazard to the immune system. They couldn't say it's known because the exposures are mixed. But anyway, that's where we are. ATSGR has recognized that organ system 2 as a target. So this is from our calculations of benchmark doses. There are various ways you can do this, and in the end, you can see that if we fix the benchmark response at 5%, a 5% decrease in antibody concentration is an adverse effect. If this is what you agree, then the benchmark concentration level is about 1 nanogram per milliliter of serum. And to achieve that, you have to have water concentrations that are more than 100-fold below. So, and if you need a safety factor, an uncertainty factor of 10, you can calculate that you need to get down toward like 1 or 2 ppt in water. So that's the short summary of this finding. There is a problem here, and that is that the serum concentration of PFAS was measured at age 5, and the outcome here was measured at age 7. Now, is the exposure at age 5 the precise measurement of the causative exposure? And the answer is no. It's not likely. Probably the infancy exposure to PFAS in this case would be a better measure. Well, if you have a situation with imprecise exposure assessment, here's the horizontal scale, and my biostatistical colleague Espen has generated this model. He has inserted an imprecision in the measurement, and you can see this is a very small imprecision. Here, this is a true measurement. Here's the the erroneous, slightly erroneous observation. This has a larger imprecision. And what happens is that the regression line that is this steep, if you look at the true observations, it becomes flatter if you don't know exactly what the exposure was at the most vulnerable time. So what we're saying is that those numbers are probably optimistic. The benchmark dose concentrations that I just showed you, they're probably optimistic. So is somebody else talking? I'm sorry, if it's a question, can we take that toward the end? Okay. Now, so what we did was to model the exposures during infancy at 3 months, 6 months, and 12 months. And this is just for tetanus and diphtheria. This is a true measurement, the concentration in cord blood here. And you can see, at least for tetanus, it's a stronger response if we use the estimated concentration at age 3 months. I'm just showing you this. It was published in the Journal of Immunotoxicology, and there's a whole lot more to it that I don't have time to review, but I just wanted you to know that we should be aware that the most sensitive time is probably very early in life, so that proper risk assessment should be based on that. I'm now going to say a few words about the COVID-19 because that may be of particular interest. And what's known about COVID-19 is that the elderly and men are particularly vulnerable, and also pre-existing disease or chronic disease, including diabetes type 2 and obesity, are risk factors. Now, in regard to the PFASs, we know that men generally have higher exposures to PFASs than women, particularly women in the fertile age groups, because they lose blood, of course, regularly, and some of them distribute some of their PFASs through pregnancy and breastfeeding, so that they have lower levels than men have. And in regard to chronic disease, we know that PFAS exposure is a risk factor for type 2 diabetes and obesity. So there's some common causation going on here. We wanted to look at that because the big mystery is, why are some people so vulnerable to the corona infection and some people get a sort of very minimal infectious disease? So here's a study that we designed, and this is something we could do in Denmark because there is a national biobank with blood samples from the hospitals. The little blood volumes that are left from diagnostic blood tests when the tests have been done, that volume is kept and stored at a very low temperature. And if you need blood from this source, you can apply for it, and you also need the IRB approval for science ethics purposes, and you can be allowed to conduct a study provided that it's anonymous. So I don't know who the participants, the 323 participants, I don't know who they are. But I know sex and age, demography, social circumstances, and the health information. I know how long they were admitted to the hospital. I know if they went to intensive care. I know if they died. But I am limited to conduct the kind of statistics that you can do on a secure server with restrictions. You can only extract information, summary information, if there's at least 5 subjects involved. You cannot get data on individuals or just 2, 3, or 4. It has to be at least 5. So anyway, under those circumstances, we were allowed to do the study without going for informed consent. And quite frankly, 17 of these people died. And I would have to go to the next of kin to say, please, will you allow me to use the blood sample from your deceased relative for scientific purposes? We didn't have to do that. So there are limitations to what we could do, but anyway, this is the information on the study. We decided, after having conferred with colleagues who work on COVID-19, that we would submit our manuscript to medRxiv, which has this document ID that's listed on this slide. So it's available. It's currently under review in the journal. We just got the peer review and we're responding to it. It was very constructive. Both reviews were very constructive. So we're hopeful that the paper will be published soon. Now, here are the findings. At least the most interesting findings. One of the PFASs, namely PFBA, which is a C4, and it's sort of a precursor, or in some cases, it's looked upon as a possible substitute for the legacy PFASs. It's the PFAS that is most widely occurring in the state of Minnesota, which I just looked at the drinking water data from Minnesota. So I think that quite likely we're all exposed to this PFAS. It's unusual in that it has a short half-life in the blood. So the concentrations in the blood are not very high. What we did here was to say, what is the proportion of these 323 participants that have detectable PFBA in the blood? And you can see this is for men and women. And so those who had short or no hospitalization, it was only about 20% that had detectable PFBA, and the proportions increased the more severe the disease was. Well, why would we find this association for a short-lived PFAS? Well, just because the half-life is short in the blood, it doesn't mean it leaves the body. There is an autopsy from Spain, autopsy study done on some 20 autopsies, and PFBA is the blue here. It's clearly the PFAS that concentrates at the highest levels in the lungs. So it leaves the blood and it concentrates in the lungs. So in summary, what we're finding is that there is a lower antibody response to at least some vaccines. We also see it with hepatitis A. Others have seen it with measles, with flu vaccine. So lower antibody responses. We've seen more frequent fever in children at higher exposures. This has been shown also in Norway, in Japan. We've seen it in Denmark. So there is this association. I know of a study which is under publication that hospitalization for pneumonia is up significantly if the child has been, during early development, been exposed to PFASs. So there's this association that we in our pilot study have found with regard to severity of COVID-19. There's evidence on other outcomes. IARC looked at PFOA and said it's a possible human carcinogen, and they pointed at immune deficiency as a possible mechanism in that regard. So the challenges is that if we're looking at compounds that have been produced for more than 70 years and almost no independent research until after 2000. And that we are looking at exposures that have been generated over a very long time. And now we're trying to make the best out of the observations that we have encountered so far. We started very late in the game. So if you look at the exposure limits, you know that EPA has lowered their recommendation, their guidelines. The most recent EU recommendation recommends a tolerable weekly intake of 8 nanograms per kilogram body weight per week. And if you translate that into a water limit for the sum of these 4 PFASs, you end up with this level that you can compare to what EPA recommended a few years ago and have not yet updated. So I just wanted to say you will meet my colleague Rainer Lohmann at the next webinar, and we're collaborating on a Superfund center called STEEP. And we are pursuing research in this area. So I think I better stop, and I want to thank you for having me present on the immune system here. Thank you.
Yeah, thanks so much, Dr. Grandjean. I really appreciate you taking the time to join us today and share that presentation and your perspective. And yeah, obviously it's decades of research allowing you to reach these sorts of recommendations or conclusions. So yeah, for folks with questions, you can type them into the chat box. A few have come up already, but before we begin the Q&A, just wanted to take a couple of minutes and hear from Alaska Community Action on Toxics Executive Director, Pamela Miller, just to provide a little bit of context on PFAS contamination here in Alaska and our efforts to modernize our own sort of local chemical legislation in the state. Go ahead, Pam.
Thank you, Nick, and thank you so much, Dr. Grandjean, for all of your work and this excellent presentation that is really so critical to all of us that are working to protect public health from this class of chemicals. I just want to spend a few minutes because I want to leave plenty of time for questions that I know people will have for Dr. Grandjean. But I want to say that PFAS pollution is a very serious public health issue here in Alaska and throughout the country and the world. We think that safe drinking water is a fundamental human right. And here in Alaska, the dispersive use of PFAS in firefighting foam that has been used on military bases and airports has contaminated the drinking water of communities from the North Slope in the far north to Southeast Alaska. And we know that at least 10 communities in Alaska have PFAS in their drinking water at levels deemed unsafe by the EPA. And we know those guidance levels are set way too high, as Dr. Grandjean just alluded to. And it's very likely that the number of communities with contaminated water will grow as more sampling is done. The sampling so far has been very insufficient, I will say. We need strong community leaders and elected officials to help solve this immense problem. And more information is available, and Nick provided the link in our investigative report called Threats to Drinking Water and Public Health in Alaska. So we urge you to take a look at that, please. And we also ask for people on the call here in Alaska, but everyone in the country really, we ask that you contact your elected officials to let them know that enacting strong and comprehensive legislation on PFAS is essential, and protecting our health should not be a partisan issue. So we're calling on legislators from both sides of the aisle to take urgent action on this issue. And here in Alaska, we really appreciate the leadership of some of our state elected officials. And I was happy to see Representative Sarah Hannon out there. And we also want to thank for their leadership, Senators Jesse Keel, as well as Representative Hannon, Representative Tarr, and Representative Zolkowski. And we're looking forward to the upcoming legislation where we hope that we can enact comprehensive legislation on PFAS that will ban all uses of PFAS chemicals in food packaging, as well as firefighting foams and textiles and other non-essential products. We want to hold the manufacturers accountable and financially responsible for cleaning up PFAS in our communities and for the harm that they've caused. We want to protect safe drinking water for contaminated communities and provide safe drinking water sources for those communities. We want to ensure that contaminated communities have access to blood serum testing, healthcare, and monitoring for early signs of PFAS-related disease. We want to ensure that disposal of PFAS does not further contaminate communities that are already historically burdened by pollution, including low-income communities and communities of color. And this includes the very harmful practice of incineration of PFAS. And finally, we really want to adopt health protective drinking water standards for the entire class of PFAS chemicals. And I want to also invite everyone to an event that we're having this Saturday called Protecting Our Drinking Water and Health in Alaska, the latest science and technology. This is part of, and the third in our Alaska PFAS Summit series. This is this Saturday, November 5th, from 4 to 5:30 p.m. Alaska time, called Protecting Our Drinking Water and Health in Alaska, the latest science and technology. And we have two very fine speakers for this as well, Dr. Anna Reed and Chris Woodruff, who will be talking about science and the science that goes into the thinking about drinking water standards, and also looking at some of the remediation technologies as well as some of the limitations of those technologies. So Nick will send out a link for all of those of you who might be interested in that. And with that, I would like to turn it back to Nick and to all of you for questions. And again, thank you all so much.
Thanks so much, Pam. And as she said, so with the remaining time, we'd like to invite any more questions or comments from the listeners. And yeah, to kick it off, there's one question for you here, Philippe, is, yeah, do you think that PFAS exposure will adversely affect the effectiveness of coronavirus vaccines that are forthcoming?
Yeah, it's a good question. I don't have an answer because the new vaccines are RNA vaccines, and it's a new principle. But I think the trick is that the vaccine will trigger generation of a protein that is typical of the coronavirus, so that the immune cells can pick up that protein and respond to it and make antibodies more efficiently than if not exposed to that RNA. But again, it's a new principle, and I think we need to study that. In my mind, it's a priority. It's an urgent issue, because there are populations in the United States, not just in Alaska, but there are areas, especially near military airports, where AFFF has been used with contaminated drinking water, people who have accumulated burdens of PFASs, and we need to know how best to protect them against COVID-19. It is possible that, what we did in the Faroe Islands when we saw the kids had not been protected by 4 vaccinations, including the booster, we gave them another booster. But of course, that helps only against tetanus and diphtheria and polio. It doesn't treat the underlying immune deficiency. And that's, of course, a concern for those communities and for the Alaskans exposed to high PFAS burdens. But at least with COVID-19, we should figure out, is there something we can do, because COVID-19 is such an acute public health emergency matter.
Thanks for that. Another question here is, so for COVID-19, they're wondering, are antibody counts the right indicator of the strength of immune protection? Are you familiar with concerns with that indicator?
Blow that by me again. I'm not sure I got the point.
They're wondering if antibody counts are the right indicator for COVID-19 in particular.
Yeah. Okay. Antibody titers. You know, I'm not thinking of. I mean, the C8 study measured total IgG and total IgM, and that's not what we're talking about. That's very crude measurements. We're talking about specific antibodies, and with COVID-19, we just have some initial methodologies that can measure antibodies. I would like to see definite IgG measurements applied in communities with high exposures to PFAS under controlled circumstances. That is, when they've gotten a shot of the vaccine. You can, of course, do a study in people who have had the disease, but you know, the antibody levels seem to decline fairly rapidly, at least in some people, after the COVID-19 infection. So yes, it is an issue, but I'd like to do this under controlled circumstances.
There's questions coming up about exposure to PFAS as well. One of our listeners writes that currently the ATSDR and AAP guidance on PFAS and breastfeeding is that the benefits of breastfeeding outweigh the risks. And they're wondering, are the recommendations different in Europe?
No, they're the same. I mean, we are all fervent defenders of breastfeeding. Human milk is the best nutrition that a mother can give to a baby. We need to protect breastfeeding, but in my mind, and this is where the real problem is, we have not paid attention to industrial chemicals that end up in human milk, so that women unwittingly are feeding their newborns with industrial chemicals rather than the nutritious human milk that evolution has resulted in. And I think that is a serious weakness of TSCA or whatever legislation that governs public health in regard to industrial chemicals. I think pollution of human health is something we have ignored for too long, and that we need to be much better at protecting.
Hear, hear. There's also another topic that seems to be coming up, is questions about where's PFAS present, which I think we've touched on a bit, but also are there ways to remove it from our environment if there's these concerns with exposure? Does anything in your research or in your experience filter out PFAS from air, water, soils?
Well, my limitation is my background is I'm a physician, and I work in epidemiology. So the way that I see it is that the PFASs belong to the group we call forever chemicals. They are persistent in the environment. And we should have been, from the very beginning, we should have been much stricter with chemicals that don't break down rapidly. And I mean, looking back, hey, we've been producing millions of tons of these chemicals, and much of that production volume is still out there. for us to consume through fish or other contaminated food, this problem is going to stay with us for decades because we didn't pay attention to it early enough.
Yeah, that makes sense. Yeah, getting back more to your expertise then. So does PFAS lower the existing antibody levels for antibody development?
Well, we don't know what's happening, across the board. There are many vaccinations, there are many infectious diseases. It looks like infectious diseases in children occur more frequently if they're exposed to elevated doses, elevated amounts of PFAS. It looks like at least several different kinds of vaccinations are impacted so that they are less efficient in creating protective antibodies. But whether that's true across the board and whether this is true necessarily also for adults, whether, let's say, the elderly are also at risk because they have a weaker immune system, less efficient antibody creation. It could be that we also need to pay attention to the elderly, whom we are now offering, flu vaccination or pneumococcus vaccinations to, because they are particularly vulnerable. And that information doesn't exist yet. So I think that there's room for a lot of more research here, unfortunately, because we've created this problem for ourselves by polluting the environment, polluting the drinking water, and still using PFAS for a variety of purposes that I don't see are all that necessary. It may be convenient, but do we really have to use persistent chemicals for all the purposes that we use them today?
Thanks for that, Philippe. Was there any question that you weren't asked or comment that you'd like to end on as we near the top of the hour?
Well, looking at the number of participants here, I'm thrilled that there's so much interest in the field. I believe that these forever chemicals constitute a very serious public health problem. And the PFAS are particularly malignant because they're toxic at such low exposure levels, and because they cross the placenta. And from the beginning of life, we are now exposed to these compounds, and then we get them in human milk, so that during early development, when our body functions, our organ functions are laid down, including the immune system functions, then we get the top exposure to these chemicals. Hey, there's something wrong with the planning here, because we have done this all wrong. And I think we need to create more attention to this, and hopefully get EPA to act pretty soon on updating their guideline. I think we need, like some states have already done, legally binding limits for PFAS in drinking water. We need to phase out the use of PFAS for all those unnecessary, I would call them, purposes that we use them for today. So I want to thank you all for being present here today and allowing me to share my thoughts with you.
Yeah, the feelings mutual, Philippe, and yeah, I want to thank you and all the participants who joined us today. I know there's a lot of questions that we couldn't get to, and I'll be going through those through the rest of the week and getting back to folks. There'll be an email as well in the next day or two with a link to the recording from today's webinar, as well as a list of related resources. So our next Che Alaska call will be on Wednesday, January 27th. we'll be joined by Dr. Gail Christopher from the National Collaborative for Health Equity for a fireside chat about the relationship between racial inequality and disparities in environmental health and justice. As Dr. Grandjean mentioned, tomorrow there'll be a CHE webinar from the National Collaborative on Health and Environment with Rainer Lohmann to continue this discussion and presentation of recent results around these fluoropolymers and their life cycles, these PFASs and their life cycles and environmental and human health impacts. Finally, I hope you'll consider making a donation to Alaska Community Action on Toxics to support these monthly CHE Alaska calls. You can give online at our website at www.akaction.org. And any additional questions or comments, please feel free to contact us by calling our office at 907-222-7714. Thanks again for sharing your time and energy so late into the evening here, Dr. Grandjean and Pamela Miller. And thanks to all of you for listening out there. Wishing you all a wonderful rest of your day.
Thanks for being part of this.
Yeah, thank you, Philippe. Really appreciate it. Yeah, I think
if any questions on the chat that I didn't respond to, I'm easy to find on the internet. And if you shoot me an email, I will respond as soon as I can.
Thanks very much. Yeah, I'll go through them and put them in a good usable format. Okay. Have a good night. Get some rest.
All right. I'm going for dinner now.
That's good. Yeah.
All right. Bye-bye.
That's funny. Thanks, Pam. Appreciate it.
Thank you, Nick. Great call.
Yeah, thanks, Margaret. Thanks for the help.
You're welcome. There's a lot of questions. I saved the chat.
Yeah, perfect. Yeah, I think that'll be a task for today and tomorrow. I'll get them into a usable format and send them along to Philippe. Let's see.